Welcome to Train Signal. You're watching a video on the fundamentals of IP version 6. In this video, we're going to start off by talking about some of the disadvantages we have of using the current version of IP, which is IP version 4. Then we'll take a look at some of the solutions that IP version 6 provides. Then we'll take a look at what an IP version 6 address looks like, and then we'll look at the different types of IP version 6 addresses that are available. One thing you need to know is that IP version 6 was developed to take on the challenges that today's growing technology has presented, which IP version 4 just can't keep up with. So here are some of the disadvantages of using IP version 4. The first one, and probably the most apparent, is that there's just not enough IP addresses available. This is something you may possibly already be aware of. There's been a lot of talk for many years about the possibility of running out of IP addresses. As a matter of fact, we would have run out of IP addresses years ago if it weren't for the implementation of technologies like network address translation, or NAT. Now, while NAT allows us to make more efficient use of the IP addresses which are available, it's still just a temporary solution. We will one day run out of IP addresses and we'll have to come up with some other solution which will allow for a larger quantity to be available. Another problem that we have is that today's internet routing tables are extremely cluttered. Now, this is because originally on the internet, we had to use what was called a flat routing infrastructure. What this meant was that every single address prefix had to have its own route entered into the routing tables of the internet backbone routers. Now, as you can probably imagine, with the growth that the internet has recently experienced, we now have tens of thousands of routes in those internet backbone routers. Another problem is that IP version 4 is very difficult to configure. Now, after watching some of these other videos, it may not seem that way, but it really is. IP version 4 presented us with two options for configuring our devices, a manual option and an automated option. The manual option, which we used to have to do, requires that somebody go out to every single device and assign it its IP address. This was quite time consuming and allows for a lot of room for error. So we moved on to an automated solution through the implementation of something called the Dynamic Host Configuration Protocol, or DHCP. Now, this simplified the process to some extent, but the reality is that we still have to maintain a DHCP infrastructure, which presents its own challenges in today's highly routed networks. Another problem with IP version 4 is that security through the use of Internet Protocol Security, or what's more commonly known as IPsec, is optional. We function in a world today where security is not really an option. So as you can see, there are many disadvantages or challenges which IP version 4 just can't handle. So let's take a look at some of the solutions that IP version 6 has given us to help deal with these disadvantages which IP version 4 has presented. First of all, as far as running out of IP addresses, it's not going to happen with IP version 6. The number of IP addresses available is a number larger than I know how to say. It's commonly presented as 3.4 times 10 to the 38th power. That is a huge number, and that is how many IP addresses are available with IP version 6. We are not going to be running out anytime soon. And as far as our internet routing tables, well, they've been dramatically simplified and made to be much more efficient by changing that flat routing infrastructure that we had before into a hierarchical routing infrastructure. This will make it much more scalable and will handle internet growth well into the future. How about this? IP version 6 gives us an easy and automated configuration solution. IP version 6 hosts have the ability to automatically configure their own IP configuration parameters without the presence of a DHCP infrastructure. Now, that's pretty cool. Now, as far as security, IP version 6 takes care of this problem as well. IP version 6 requires the presence of IPsec. It is no longer optional. So, really, as you would expect, IP version 6 addresses all of the challenges which we are currently presented with in IP version 4. So let's take a look now at what an IP version 6 address looks like. In IP version 6, our addresses are 128 bits long. Yes, That means there are 128 ones and zeros in this address. That is way too much for anyone to have to look at. So what we're going to do is we're going to take the 128 bits that you see here, and we're now going to divide them into 16-bit chunks, then take those 16-bit chunks and convert them into a hexadecimal number, which gives us an IP address that looks like this. So here you see we end up with 8 hexadecimal numbers separated by colons. Now we can further simplify this by suppressing the leading zeros. This is something we are already used to doing in the traditional decimal numbering system. If I were to write down the number 0049 and ask you what that number was, you wouldn't say 0049, you would simply lop off those first two zeros and say 49. This concept holds true with hexadecimal numbers as well. See here we have 05EE, 00FF, and 0238. Well, we can get rid of these leading zeros and end up with this guy right here. Okay, you'll notice the 5EE, we no longer have a zero in front of it. FF no longer have the zeros, and 238 no longer have the zeros. Now there's still one more step. We can further compress this address by expressing a single contiguous set of blocks with a value of 0 into a double colon. So in the example I have here, let me get rid of some of that. You'll notice that we have right here in the middle, near the beginning, we have 3 zeros all in a row. What we can do is we can take that and turn that into a double colon to represent those zeros. And what we end up with is our final IPv6 address, which looks just like this. Now, if you're thinking that this is still more complicated than the average person can handle, well, it is. IPv6 was not designed for the average person to understand. IPv6 has been designed with such simplicity in its configuration that the only people who need to understand these addresses are the network administrators who are going to take the time to fully educate themselves on this technology. So now that we've seen what an IP address looks like, let's talk about the different types of addresses that are available in IPv6. In IPv6, there are 3 different types of addresses. 2 of them are very similar to what we had in IPv4, and 1 is brand new to IPv6. Now, I spoke about these in a previous video, but let's take a look at how they apply here in IPv6. Now, the first one is just like one we had in IPv4. It's something called a unicast address. This address is used for one-to-one communication. One sender, one recipient. Now there are actually 3 different types of unicast addresses in IPv6, and they somewhat closely relate to the different types of unicast addresses we had in IPv4. The first one is known as a global address. The global address is what was previously known as a public IP address. These are addresses which are available to be used on the internet. These addresses will be recognized by the internet routers. The second type of unicast address is what's known as a link local address. A link local address is just like the old automatic private IP addressing or a PIPA address, where you have a host which self-configures itself with an IP address. Now, unlike the old APIPA addresses, which were very restrictive and could only be used in a very small private network, link local addresses are much more dynamic and can be used in much larger networks. Now, you can recognize a link local address by looking at the first block in the IP address. It will always start with FE80, and this is how you would know that you were looking at a link local address, is by looking at that first block. The third type of unicast address is a unique local address, and this is very similar to the old private IP addresses. I spoke about in a previous video about how in IPv4 there were certain blocks of addresses which were reserved for private use only and are not valid on the internet. Well, that is what a unique local address is in IPv6. There are 2 blocks which fall into the unique local address range. The addresses will always start with either an FC or an FD. So any IP address which starts with either an FC or an FD has been reserved for private use only and is not valid on the internet. Now, the second type of IP version 6 address is essentially identical to what we had in IP version 4. It's called a multicast address. A multicast address is used when we have one-to-many communication. This is where you have one sender and many recipients who all subscribe to that multicast IP address to receive the transmission. This is typically used with something like streaming audio or streaming video communications. Now, unicast and multicast addresses, as I said before, also existed in IP version 4. But the one new type in IP version 6 is the anycast address. This is an address which is used where we have one-to-one of many communication. Now, this is how it works. Basically, in an anycast environment, we have a set of interfaces known as the anycast group, which listens on the anycast address. So we have a group of devices which are all listening on the same address. When a host sends something to that address, the packet is then delivered to the anycast group member, which is closest to that host. So what happens here is we actually have one-to-one communication, just like a unicast, but the one recipient is one of many recipients who all subscribe to the anycast address, which is just like a multicast. So anycast is kind of like taking unicast and multicast and bringing them together to create this new form of communication. So these are the three types of addresses which are available on an IP version 6 network. Well, that brings us to the end of this video, and at this point, you should now understand how IP version 6 solves the problems that we're currently facing with IP version 4, and you should know what an IP version 6 address looks like.